Automatic watches introduce a level of autonomy that transforms the relationship between the wearer and the timepiece. Because instead of relying on deliberate action, they harness the natural motion of the human body. And what is particularly fascinating is how these modern materials coexist with traditional craftsmanship, creating movements that are both rooted in centuries-old techniques and enhanced by cutting-edge science. Because not all mechanical watches are created equal in terms of accuracy, and certain institutions have established rigorous testing standards to evaluate performance under controlled conditions. This video takes you on a deep and fascinating journey into the intricate universe of mechanical and automatic watches, revealing the invisible choreography of precision engineering that transforms simple motion into the measurement of time. Timeless, rare, unmatched, a watch is more than an accessory. It's a reflection of your standards, your ambition, and your presence. Each piece we offer is carefully curated for those who refuse the ordinary. Exclusive models, limited availability, private sourcing on request. Enjoy 10% off the entire catalog by sending the code CHRONO24 via Instagram. If you're ready to elevate your collection, send me a DM to access our current selection and check the link in bio for available pieces. Serious inquiries only. If you take a moment to look at a mechanical watch resting quietly on your wrist, it may seem almost ordinary. Yet inside that small case exists an entire universe of controlled energy, where every component plays a precise and indispensable role. And to truly understand how it works, we have to begin with the very origin of its power. Because unlike electronic devices that rely on batteries, a mechanical watch stores energy physically, in the form of tension accumulated within a tightly wound strip of metal known as the mainspring. And when you wind the crown, you are not simply turning a knob. You are actively compressing potential energy into that coiled spring, forcing it into a state where it constantly seeks to return to its natural shape. And this desire to unwind becomes the driving force of the entire mechanism. Yet what makes this system remarkable is not the presence of energy itself, but the way it is controlled. Because if the mainspring were allowed to release all its energy at once, the watch would spin uncontrollably and stop almost instantly. So the challenge that watchmakers solved centuries ago was how to take this raw, continuous force and transform it into something slow, stable, and measurable. And this is where the architecture of the movement begins to reveal its brilliance. Because every wheel, every pivot, every surface has been designed to guide energy step by step, reducing speed while preserving consistency. And as the mainspring unwinds gradually, it transfers its force into the gear train, initiating a chain reaction that will eventually result in the steady movement of the hands. But at this stage, the motion is still far too fast and far too irregular to measure time accurately, which means another level of control is required. And understanding that need for regulation is the key to appreciating the genius behind mechanical watchmaking. To regulate this flow of energy, mechanical watches rely on one of the most ingenious inventions in horology, the escapement, a mechanism that acts both as a gatekeeper and a metronome. And its role is to interrupt the continuous release of power from the mainspring and divide it into equal measurable portions. But it does more than simply block and release energy. It also sustains the motion of another essential component, the balance wheel, which is responsible for keeping time through its constant oscillation. And if you imagine the balance wheel as a tiny pendulum rotating back and forth, you begin to see how time is actually created inside the watch. Because each oscillation represents a fixed unit, a beat that can be counted. And attached to this wheel is an extremely fine spiral spring called the hairspring, which expands and contracts with each movement, providing a restoring force that ensures the oscillation remains consistent. And the interaction between the escapement and the balance wheel is incredibly delicate, because with every swing, the escapement locks and unlocks, delivering a small impulse that keeps the balance wheel moving while simultaneously advancing the gear train by one precise increment. And this repeated interaction produces the familiar ticking sound, which is not just a byproduct, but a direct expression of the watch dividing time into equal segments. And what is truly fascinating is that this entire process happens several times per second, continuously, without interruption. And its accuracy depends on an intricate balance of forces, including the elasticity of the hairspring, the inertia of the balance wheel, and the minimal friction between components, meaning that even the slightest imperfection can affect performance. which is why watchmakers devote immense attention to adjusting and refining these elements, transforming what could be a simple mechanism into a highly precise instrument. As the escapement releases energy in controlled impulses, that energy continues its journey through the gear train, a system that serves as the translator between raw mechanical force and the visible passage of time. And this translation is achieved through carefully calculated gear ratios, where each wheel turns at a different speed, progressively slowing down the motion as it moves further from the mainspring. And the brilliance of this system lies in its mathematical precision, because the number of teeth on each gear is not arbitrary. It is chosen to ensure that the rotations correspond exactly to seconds, minutes, and hours. And this means that when the final wheel in the sequence completes a full rotation in 60 seconds, it drives the second hand, while other gears convert that motion into slower rotations for the minute and hour hands. And what makes this even more impressive is that all of this happens simultaneously, with multiple layers of motion occurring at different speeds, yet remaining perfectly synchronized. And beyond its functional role, the gear train also reveals the aesthetic dimension of watchmaking, especially in high-end timepieces, where the components are decorated with intricate patterns, polished to a mirror finish, or engraved with delicate motifs, turning a purely mechanical system into a visual spectacle. And when you observe a movement through a transparent caseback, you are not just seeing gears turning, you are witnessing the physical embodiment of time being constructed in real time, driven by principles that have remained fundamentally unchanged for centuries, yet continue to inspire innovation and admiration. While traditional mechanical watches require manual winding to replenish the energy stored in the mainspring, automatic watches introduce a level of autonomy that transforms the relationship between the wearer and the timepiece. Because instead of relying on deliberate action, they harness the natural motion of the human body, converting everyday gestures into a continuous source of power. And this is made possible by the rotor, a semicircular weight that rotates freely within the watch, responding to movement through gravity and inertia. And as the wearer walks, gestures, or even shifts position slightly, the rotor swings back and forth, engaging a winding mechanism that transfers this motion into the tightening of the mainspring, effectively capturing kinetic energy and storing it for later use. And what makes this system particularly sophisticated is its ability to function regardless of the direction of movement, thanks to reverser gears that ensure efficiency whether the rotor spins clockwise or counterclockwise. And at the same time, the mechanism must prevent excessive tension, because overwinding could damage the mainspring. So engineers develop slipping bridle systems that allow the spring to disengage once it reaches optimal tension, ensuring both safety and longevity. And this combination of responsiveness and protection illustrates the level of thought that goes into even the smallest details, making automatic watches not just convenient, but also remarkably resilient, capable of sustaining themselves indefinitely as long as they remain in motion. Despite their elegance and ingenuity, mechanical and automatic watches face a constant challenge when it comes to accuracy, because unlike quartz watches that rely on electronic oscillations, they are influenced by a wide range of physical factors, including temperature changes, gravitational effects, and positional variations. And to address these challenges, watchmakers focus heavily on regulation, the process of fine-tuning the movement to achieve the most consistent rate possible. And this involves adjusting the balance wheel and hairspring assembly with extreme precision, sometimes altering the length of the hairspring by microscopic amounts to change the frequency of oscillation. And in more advanced designs, additional features such as adjustable weights on the balance wheel or specialized alloys that resist thermal expansion are used to improve stability. And one of the most fascinating aspects of this process is the concept of positional accuracy, because a watch may run slightly faster or slower depending on how it is oriented. And skilled watchmakers take this into account, testing and adjusting movements in multiple positions to minimize variation. And while it is true that mechanical watches cannot match the absolute precision of quartz technology, their appeal lies in this very complexity, where timekeeping becomes a dynamic interplay of forces rather than a fixed electronic signal, giving each watch its own subtle personality, shaped by the environment in which it operates. Beyond their technical function, mechanical and automatic watches carry a profound cultural significance that extends far beyond the measurement of time, representing a tradition of craftsmanship that has been refined over centuries, where knowledge is passed down through generations, and where each movement reflects not only engineering expertise, but also artistic vision. And in a world increasingly dominated by digital technology, these watches offer something fundamentally different, a tangible connection to the physical principles that govern motion and energy. And this connection creates an emotional resonance that cannot be replicated by purely electronic devices. Because owning a mechanical watch is not just about knowing the time, it is about appreciating the intricate work that happens beneath the surface, the countless interactions between components that must remain perfectly coordinated to function correctly. And this appreciation often transforms these objects into personal artifacts, carrying stories, memories, and meaning that evolve over time, making them not only instruments, but also companions that accompany their owners through different moments of life, reinforcing their enduring relevance in a rapidly changing world. When you step back and consider everything that happens inside a mechanical or automatic watch, it becomes clear that these devices are far more than simple tools. They are miniature ecosystems where energy is captured, controlled, and expressed through motion. And this motion, in turn, becomes our way of understanding time, not as an abstract concept, but as something that can be seen, heard, and even felt. And this is perhaps what makes mechanical watchmaking so captivating, because it transforms an invisible dimension into a physical experience, allowing us to witness the passage of time through the interaction of gears, springs, and oscillating components, all working together in perfect synchronization. And even as modern technology continues to push the boundaries of precision and convenience, mechanical and automatic watches remain a testament to human ingenuity, demonstrating that complexity and beauty can coexist within a single object, and that sometimes the most fascinating solutions are not the most advanced in terms of electronics, but the ones that rely on fundamental principles, carefully refined over generations, to create something that is both functional and profoundly inspiring. As we continue exploring deeper layers of mechanical and automatic watches, the role of materials becomes impossible to overlook, because every single component inside the movement is subject to forces that, although small in scale, are relentless over time. And the choice of material directly determines how well each part resists wear, deformation, and environmental influence. And historically, watchmakers worked primarily with brass for plates and bridges due to its machinability, while steel was reserved for components requiring strength and resilience, such as springs and pinions. But as the demands for precision increased, so did the need for innovation in materials, leading to the introduction of synthetic jewels, typically rubies, which are placed at nicots of high friction like pivot holes, to dramatically reduce wear and improve efficiency. And this use of jewels is not decorative in origin, but entirely functional, allowing rotating exat to move with minimal resistance while maintaining alignment over long periods. And in more recent developments, materials such as silicon have revolutionized certain critical components, like the escapement and hairspring, offering near-perfect resistance to magnetism and significantly reducing the need for lubrication, which itself is a major factor in long-term performance. And what is particularly fascinating is how these modern materials coexist with traditional craftsmanship, creating movements that are both rooted in centuries-old techniques and enhanced by cutting-edge science. And this balance between tradition and innovation ensures that watches continue to evolve without losing their identity, maintaining a continuity that is rare in other fields of engineering. When discussing mechanical watches in greater depth, it is essential to explore the concept of complications in a more immersive way, because these additional functions represent the pinnacle of watchmaking creativity and technical mastery. And a complication is not simply an added feature. It is a complete rethinking of how energy is distributed and controlled within the movement, requiring layers of idafia mechanisms that must operate in perfect synchronization with the base timekeeping system. And for instance, a chronograph introduces an entirely separate system of gears and levers that can be engaged or disengaged at will, allowing the measurement of intervals without interrupting the continuous operation of the watch. And this requires an intricate coordination between clutches, column wheels or cam systems, and reset hammers, all working together in a sequence that must be both precise and reliable. While more complex complications such as perpetual calendars take this even further by incorporating long-term cycles into the mechanism. effectively programming the watch to recognize the varying lengths of months and the occurrence of leap years, sometimes for decades or even centuries without adjustment. And then there are poetic complications like the minute repeater, which transforms time into sound by striking small gongs within the case, allowing the wearer to hear the time rather than see it. And all of these examples highlight the extraordinary level of ingenuity involved, where watchmakers are not just solving problems, but expanding the very definition of what a mechanical device can achieve. Over time, even the most precisely engineered watch will begin to experience subtle changes in performance, not because it is poorly made, but because it is alive with motion, constantly operating under conditions that inevitably lead to gradual wear. And this is why maintenance is not merely recommended, but essential, forming an integral part of the life cycle of a mechanical or automatic watch. And the process of servicing is both meticulous and deeply technical, beginning with the complete disassembly of the movement, where each component is carefully removed, inspected, and categorized. And this alone requires a level of precision and organization that can only be achieved through years of experience, because the smallest screw or gear must be handled with care to avoid damage. And once disassembled, the components are cleaned using specialized solutions designed to remove old lubricants and microscopic debris, restoring surfaces to their optimal condition. And after cleaning, the watchmaker reassembles the movement, applying fresh lubrication at specific nakats, using quantities so small that they are often measured in fractions of a drop. Because too much oil can be just as harmful as too little. And finally, the watch is regulated and tested across multiple positions to ensure consistent performance. And this entire process not only restores functionality, but also extends the lifespan of the watch, reinforcing the idea that these timepieces are not disposable objects, but enduring systems designed to be cared for and preserved. Wearing a mechanical or automatic watch is an experience that engages more than just the sense of sight, because it introduces a subtle yet constant awareness of time as a living process. And unlike digital displays that present time as static numbers, a mechanical watch expresses it through motion, through the continuous sweep or incremental steps of the hands, through the rhythmic ticking that can sometimes be heard in quiet moments, and even through the tactile sensation of winding the crown, where resistance builds and releases as the mainspring is tightened, creating a direct physical connection between the wearer and the mechanism. And this connection is further enriched by the knowledge that the watch is responding to movement, especially in automatic models, where each gesture contributes to maintaining its operation. And this creates a relationship that feels almost reciprocal, as if the watch depends on the wearer just as much as the wearer depends on the watch. And over time, this interaction can become deeply personal, with the watch reflecting the habits and routines of its owner, gaining character through use, and developing a presence that goes beyond its function, making it not just an accessory, but a companion that accompanies daily life in a quiet and consistent way. As we reach the final stage of this exploration, it becomes clear that mechanical and automatic watches represent far more than the sum of their parts, because what they ultimately embody is a philosophy of time that is fundamentally different from the one offered by modern electronic devices. And this philosophy is rooted in the idea that time can be experienced through motion, through the interaction of physical forces that unfold in a continuous and observable manner. And when you consider the entire system, from the mainspring storing energy to the escapement releasing it in measured increments, from the gear train translating motion into readable form to the rotor capturing movement from the wearer, you begin to see how every element contributes to a unified whole, where nothing is unnecessary and everything has a purpose. And this sense of coherence is what gives mechanical watches their enduring appeal, because they offer a form of transparency that is increasingly rare, allowing us to understand not just what they do, but how they do it. And in doing so, they invite us to engage more deeply with the concept of time itself, transforming it from an abstract measurement into a tangible experience. And perhaps that is why, even in a world driven by speed and convenience, these watches continue to captivate, reminding us that complexity, patience, and craftsmanship still have a place, and that sometimes the most meaningful way to measure time is not the most efficient. If we push the exploration even further, we begin to encounter the extreme edge of watchmaking, where precision becomes an obsession and innovation turns into experimentation. And this is where concepts like chronometry and certification come into play. Because not all mechanical watches are created equal in terms of accuracy, and certain institutions have established rigorous testing standards to evaluate performance under controlled conditions, measuring how consistently a watch keeps time across different positions, temperatures, and durations. And achieving such certification is not simply a matter of assembling high-quality components. It requires an extraordinary level of fine-tuning, where each variable is carefully adjusted to minimize deviation. And beyond standard regulation, some watchmakers go even further by developing mechanisms specifically designed to counteract the effects of gravity, such as the tourbillon, a rotating cage that houses the escapement and balance wheel, continuously changing their orientation in order to average out positional errors. And while the practical benefits of such mechanisms are often debated in modern contexts, their existence represents a relentless pursuit of perfection, where the goal is not just accuracy, but the demonstration of technical mastery. And this pursuit extends into areas such as high-frequency movements, which increase the number of oscillations per second to improve stability, as well as experimental escapements that aim to reduce friction and energy loss even further. And taken together, these advancements show that mechanical watchmaking is not a static tradition, but a living discipline that continues to evolve, driven by curiosity and the desire to refine what is already an incredibly sophisticated system. Ultimately, when everything is considered in its full depth, mechanical and automatic watches reveal themselves as more than instruments of measurement. They become reflections of how humans relate to time, because unlike digital systems that prioritize efficiency and invisibility, these watches make time tangible, allowing it to be observed, heard, and even felt through the steady rhythm of their operation. And this tangible quality changes the way we perceive its passage, encouraging a slower, more attentive awareness, where each second is not just counted, but expressed through motion. And this is perhaps why so many people are drawn to mechanical watches despite the availability of more accurate alternatives, because they offer something that cannot be replicated by electronics: a sense of continuity, a connection to tradition, and a visible reminder that time is not just data, but a process that unfolds continuously around us. And in wearing such a watch, one carries a small, intricate world on the wrist, a world where energy flows, components interact, and time is created moment by moment. And this realization transforms the object into something far more meaningful than its function would suggest, making it not just a tool, but a symbol of craftsmanship, patience, and the enduring human fascination with understanding and measuring the passage of existence. And if you've made it this far, you now understand that a mechanical or automatic watch is not just about telling time. It is about witnessing time being created through motion. So the next time you glance at your wrist, take a second longer, listen to the rhythm, imagine the invisible dance happening beneath the surface, and remember that within that small object lives a centuries-old story of human ingenuity, precision, and passion. And if you enjoyed diving into this world, don't forget to subscribe, because there are many more hidden mechanisms, ideas, and stories waiting to be uncovered together.